Do you breed chickens, but the chicks are now becoming too big for the brooder, but they're still too small to go in the chicken pen? Come along with me and I'll show you how to make a mobile chicken pen using recycled and leftover materials. Let's go. Hey guys, Musa here from Quantum Home Improvements and Solutions. Welcome back to the channel. So just recently I incubated some chicks and they've hatched and they're doing really well. But very soon they're going to need to be put into the chicken coop, roughly when they're around about 2 to 3 weeks old, after they've got a bit of feathers. So the only problem with that is that the chickens themselves will peck at them and potentially kill them because they're very territorial. So a solution to that is to put them into another coop. And finally, I've decided to make a mobile chicken coop, roughly 3 metre by 1.5 and with a 5-degree pitch roof. So the reason I'm doing this, because there's 3 benefits to it. First of all, these chicks are for our own consumption and I need them to grow pretty quickly because you normally dispatch chickens around about 10 weeks old, give or take. So a good way for that to happen is to feed them on grass, free range them. Our soil quality here is quite bad, and instead of spending money on trying to fix it, this is a perfect solution because the chicks will dig into the soil, they'll eat the grubs, they'll eat the grass, their droppings will actually feed the grass with their manure and put some nitrogen and some carbon back into the soil, and also it'll help the chicks grow faster and protect them from the elements from the animals and everything else. A while back my compound drop saw died on me after building a couple of houses and doing a lot of renovations. And I didn't end up replacing it straight away, but in more recent times, I bought a El Cheapo. And as the old saying goes, the bitterness of poor quality remains long after the sweetness of low prices are forgotten. And that thing was a disaster. So anyway, this was on special recently at Bunnings, and so I decided to buy it. And so it's not the top-end Makita, but Makita's a really good brand. And this is going to do everything I need it to do. So the cutting size on this is a 255, a 10-inch or thereabouts, and the model number is LS1017L. So this is going to be the main tool that I'm going to be using to make this mobile chicken coop. So now I'll just undo the box and get this drop saw ready. Okay, so now I'm going to set up. But the first thing I need to do is just put this saw together. Put the dust bag on. So this drop saw comes with a laser. And so this is to help when you mark your timber to cut right on the line. First, I'm going to start with the walls. And now, so the height of this back end of the chicken coop will be 860 mil. And that's going to taper down to 600 mil. Now I'm going to throw a few figures here and you might get lost. So this timber is 35 mil thick. Now, when you're making walls, the bottom plate goes past the studs. So the plates are like that and the studs sit on top. Okay, so now, if I want 860, I have to minus the top and bottom thickness of timber, which means that I have to take off 70 mil. So I'm going to cut these timbers 790 and also allow a 5-degree fall for the roof to come down. So I'll cut those for the walls. Then I'm actually going to do the butt walls as well. And so the butt walls will be that measurement, 860, and then also 600 on the low end. These timbers that I'm using are all recycled from the formwork that I've done recently. So these are H3 timbers, and which are termite proof timbers. The difference between a H2 and a H3 is that the H3 is used externally. You could use a H4 or a H5 as well, depending on how much moisture is going to be on the timbers. I might actually use the laser here. And then I put the saw on a 5-degree angle so it can have a fall on the roof. So I'm using corrugated sheeting, Colorbond sheeting, and so the minimum you can have on Colorbond corrugated is 5-degree fall. This saw cuts beautifully. So you can see that slight angle. Now, when we're making the back wall, the butt wall to the side walls, we measure from the smaller side, not the bigger side. So the front is 600 mil and minus the top and bottom plate, 70 mil. So that's going to bring it down to 530. So now I'll cut the top and bottom plates. So some of these timbers still had a bit of nail in them from the formworking. So as I'm using them, I'll take out the ones that will have the nails in my way. Okay, so now I've cut the bottom plates. Now I've got to cut the top plates. And so the top plates are 11 mil longer than the bottom plates. And the reason I know that is because I got my daughter to do the calculation using trigonometry. So yes, I cheated. Remember guys, measure twice, cut once. So with these butt walls, they need to be minus 140 mil. So remember that the outer parameter timbers that are 70 mil each, so you've got to do 70 plus 70, it's 140, and you need to minus that off the width because these are the butt walls. These are the walls that sit inside the outer walls. So I've just discovered that the corrugated iron overall is 1600 with 2 sheets, and I want to make it pretty much the same size as 2 sheets so I don't have to cut it. So if it's 1600, then I'm minus 140. So that leaves me 1460. Okay, so now using my Pasla nail gun, my framing gun, I'm going to put this all together. Okay, so I'll put the first wall together, which will be the butt wall. I fire 3 nails into every joint. Okay, so this is the back butt wall. Don't forget your PPE. Always use your PPE. Glasses and earmuffs, especially with carpentry. Things go flying around all the time. Even though this doesn't have the loading as a house would, I'm still going to make put 2 more studs in here and put the centers closer together. Just stop that twisting of the timbers, and also when the tractor's pulling it, it's going to need a lot of strength so it doesn't damage it. Okay, so the back wall's a little bit different. I need an escape hatch for the chickens to get out. Now, I'll just make the side walls. So here I'm just going to do 600 centers. So I've cut all the studs, tapering down, and I've written the measurements down so I can duplicate the other side, make it a bit easier. So now I'll just go ahead and just nail it all in. Reload. 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 Okay, so all the walls are now complete. Now I'm going to put them all together. So now I just use this butt wall and place it in between here where I've got this trim, and that'll be nailed to the trim and also to the stud. Now, so to square this off, I'm going to put some steel straps, place them from one corner to the other, and wrap them around the top plates and get that thing squared off. And also on the bottom here, I'll be putting some bracing as well. So now just use more recycled timber. This is a 190 by 45 H3 timber, so it's termite proof as well, and it's a structural timber, and I'll be using this for the bracing of all the corners. So I'm just cutting out triangles at 45 degree. Okay, so I'll just place this timber into the corner, make sure it sits in square. Reload. So now to give strength to these bracing, I'm going to put a timber across the top of them. Reload. Let it go down, please. So now I'll just cross-check the measurements between the two diagonals to see if this is square up above. The bottom is square, but the top I'm not sure about. It's actually not too bad at all. It's almost spot on. So what I'm going to be doing here, I'm just placing these little supports that will carry the rafters across. Now, this will not be a trafficable roof, so I'm not going to structure it very solid. So this is a 70mm timber, top plate, and the supports are 90mm, and so what that's going to allow, 20mm for the ceiling joist to sit on, and then I'll fasten it. Reload. Reload. So I've cut the metal bracing, and I'm going to go from this corner to the diagonal corner, and I've allowed 350mm to go over because I'm going to strap it around this corner. And so on the other diagonal, I'm going to go from this corner and come short, just one stud, because I need to allow room for the actual lid to put all the feeders in, the water and the food feeders. Now, usually at every point that you're fixing, you put 2 Prado nails, which are made for this bracing. But in this case here, I'm only going to put 1 for now, and then come back after because I need to swivel it around. Sort of just mold it a little. So before I put the next strap on, go in the other direction, I'm actually going to use a tensioner and bring in this corner because this is just slightly out in square, only by a short amount. So the way this tensioner works is quite simple. Place the screw on top, you place the bracket on the bottom, so just tighten up the wing nut. Spot on. So now using my 4-inch 100mm disc cutter, using the Irwin brand, just going to cut this piece, 580mm. The height I need there is 600, but I'm going to come off the ground so this doesn't rust. I will nail it together using Paslow staples. So now using these C-channels, I'm going to place them on the outer door. So these are a 25mm by 25mm C-channel, and they're offcuts from another job. So after pre-drilling my channels, I now just screw them in. I'm allowing it to come past the studs by only 10mm. That way it gives a lot of room for the corrugator to fit inside. I can fasten into this stud. So I'm making this a wire door, purely to make it more accessible. But the benefit of it is that it's going to get a cross flow of air. Now it's very tight. All right, so I finished cross bracing on the top. Now for the bottom, I'm also going to put some bracing, but I won't be using a strap because it could actually hurt the chickens. So I'm going to use timber. I'm going to run it from the diagonals. Okay, so now I'm going to cut the Colorbond. There is a right and a wrong side. So the corrugator is going upwards on this end. I'm going to put that facing the ground. And because of the capillary reaction, because of an electro field, I don't want the water to capillarate around into the chicken coop. I want it to kick off. So now I'll just measure it. So the height here will be 600 minus 15mm. I want to get it off the ground. And I'm just going to taper it to the top end of the other side. Okay, so now I'm going to cut the back section, and the back section is just 1610. Okay, so all I've got to do now is just cut out the door. So it's going to be 450 high and 410 wide. Okay, so using a hex head, type 17, 50mm screw, I'm going to use that for the cladding and also for the roof. Okay, so I'm doing every third corrugation, but when you're doing screws into walls with corrugated sheeting, you do them in the valleys, not on the ridges. All right, so I'm going past the sheeting a little bit so the roof can be protected from the water going in. I'm also placing the corrugator going downwards this side, and this side goes up. When the latch closes, I want it to overlap over this sheeting. When you're screwing the roof in, you screw it on the top of the corrugation, not in the valley. So, and you do every third corrugation. So it's this one, 1, 2, 3, this one, 1, 2, 3, this one, then 1, 2, 3, 4. So the pattern is 3, 3, 4. And be careful not to crush it down too far. Okay, so now we know where the sheet finishes, and we can place our timber just right up against it, and then we can make our door. Lock that in. Lock that in. So I've totally run out of timber, so I'm just using anything I've got now, and it'll still work because I'm going to screw the Colorbond onto this and they'll hold it together really well. So I have missed a crucial step. I've put this back sheet on before putting the hinges on. I'm going to use T-hinges, they're 250s, and zinc plate. So what I'm going to do is just remove a few of these screws so I can put the hinges on. So what I'm basically going to do is screw these hinges just to the edge here. Now I'll just screw the door on. There we go. Beautiful. Okay, so it is sticking up just a little bit here. I'm not too concerned about that. It's still going to be watertight. Let's see how this opens up. Beautiful. So this is an old harness rope that I used to use. I don't use it anymore. It's a little damaged and I don't need it really. So I'm going to use this rope to pull this mobile chicken coop around. I'll have one in the front and one in the back. So I'm going to drill the holes through and put the ropes through. from the inside I place a knot, squeeze that through as tight as I can, and so I melt the ends to make sure they don't fray, and then I'll pull that through. Okay, so the chicken coop is almost finished. I've just got to put the sheets on both sides, which I've already cut, and then it's ready to go. It's done. The mobile chicken coop is now complete and it works really well. It slides on the grass beautifully, and the cross bracing has made it very rigid and very solid, and I'm very happy with it. And the chicks look very happy inside. And this Makita LS1017L did a great job in helping me build it. And it's around about the mid-range of the Makita products in the compound saws. And you can get a better model than this. You probably pay twice the price, but for what I need, it did a great job. And now if you don't have a distributor in your local area that sells these saws, I will put a link below for Amazon for a similar product. This particular one is only sold at Bunnings. It is discontinued, but there is an LS1018, which is a little bit better than this model, a little bit more expensive. So that's the end of this video. I hope you enjoyed it. I hope you got something out of it. And I've got plenty more videos coming, and I'd ask if you please consider to subscribe and hit the like button, and I'll see you on the next one. Thanks, guys.